All right, Foundations of Algebra. I'm on my tablet here, so I'm going to share my screen, and then I'll see you later because I don't really know what happens once my screen is shared. I can't see myself. All right, so we are doing intercepts. Well, it's called intercepts, but we're actually, jumping into the slopes and intercepts together. All right, so we have quiz 1 there, which covers the intercepts. We have relating linear context to graph features, slope, intercepts, and context, linear equation word problem tables, graphs, and graphing linear. So lots of word problems. All right, so get a pencil, get ready, and let's go. Okay, so can I zoom out here? What? No, okay. Igor's summer job at the frozen yogurt shop paid him following amounts in his first 3 days on the job. Okay, okay. First 3 days on the job. And so we want to know what is, okay. Let's just use the annotation there. We want to know what is, okay, how do I get out of this? This is just, all right. What is Igor's unit rate of change with respect to time? That is, how much is he paid for 1 hour of work? What do you think? Well, in 6th grade, we do unit rate. So we can take, and if it's constant, then we could divide and find out in any pair here. So let's see, if we do 57 divided by 6, because that's 1 day, right? So he got $57 for working 6 hours. That works out to 9.5. $9.5 per hour. So let's see if we get the same thing when we do 85.5 divided by 9. And what's that? Hey, 9.5. So you see, and then even if we took that one, we did 66.5 divided by 7. What do we get? And I'm actually doing it 9.5. So there you go. The unit rate, if you know you have a unit rate, then you can divide any pair and you'll get it. And in this case, it's 9.5. 9.5 graph the proportional relationship. And then the nice thing is, if it has that unit rate, then we can just graph, well, 9.5, but we can graph any of these. How about 657? Can I graph 657? I don't have enough. Okay, so I got 9.5. So I could graph 1 and 9.5. There's 9, so there's 9.5. And where is 1? Is it 1 right there? 1 would be 1, 2, 3, 4. So 1, 2. So straight up. I think I got it. Let's see. Woo! We got it. All right. Which order pair is the solution? So we did this earlier, so I'm just skipping that. We did this one last video as well, didn't we? Did we do that? So I'm skipping that. Okay, and I just did this. Whoa. Okay. It's a little different. Graph the line that represents the proportional relationship between y and x, where the unit rate of change is 0.4. In other words, every 1 is 0.4. So that means if it's proportional, it goes to 0, 0, and 1 goes to 0.4. But hey, I don't know if we can really graph 1.4. So 2 would be 0.8, 3, I run out of room. Okay, so 3 would be 1.2, 4 would be 1.6, 5 would be 2. That is the magical coordinate that I want to graph. 5, 2. And why? Because it's not a decimal. So there we go. The equation is y equals, 1 second, stop share. Oh, there we are. All right, now here we are back. Portion of the house. Find out where were we? Okay, so the equation is, well, that's the easy one. We got the rate of change is 0.4. So the equation is just going to be y equals, where's my y? Well, x equals, how do you get to the y? Oh, okay, x, y, interesting. Y equals 0.4 x. Okay, whew, glad I got that one. Complete the missing value. You can do that. You don't need me for that. Oh, guess what, you guys? You're going to do so great on that quiz. I'm not even worried about it. All right, moving on to relating linear context to graph features. Okay, so let's talk about this. We have slopes, we have intercepts. We need to take some notes. So the y-intercept is the point 0b. The x-intercept is the point a 0. Okay. And we know that y equals mx plus b, right? From accelerated 2. M is the slope, as we talked about. B is the y-intercept. Okay, so how do we know when we have something? It's all about the units. So identify the units, okay, which is the word after the number. A unit is a word that describes a number. So sometimes it's a symbol like this. What's the unit there? It would be, we would write $25, right? And then here we see $25 again. Any other units here? I see each vertical meter. So that means 1 meter. So our units are meters, vertical meters in dollars. And we see that here. Y represents dollars. X represents vertical meters. Okay. So we have that. So let's read this. Burrow Travel Bureau arranges trips for descending into the Grand Canyon. For each trip, they charge an initial fee of $25. So that's another one. Initial fee. So our initial starting, beginning. These words clue you into the y-intercept. The y-intercept is where a situation starts. So what do you think about the x-intercept? The ending, when something hits the ground, maybe, is the x-intercept. And the slope, well, that's the rate of change. Okay, this is getting sloppy, so I'm going to clear it, but remember all of that right there. All right. So we have 25, the initial fee of $25. That's the y-intercept. And in addition, they charge that for each vertical meter. So let's give you some slope keywords. Well, there's one right there. For each, for every, per, you know, these are slope keywords. So we know that right here we have the slope and the y-intercept. So let's do another one, see if we get some more keywords here. All right. Naoya, Naoya read a book cover to cover in a single session at a rate. There we go. That's a slope keyword, right? Rate. So there's a slope and then per. Lots of keywords. And then after 4 hours, he had 350 pages left to read. So here we have 4 hours, 350 pages. So we know our units are hours and pages. So each ordered pair has an x value and a y value, and the x value represents a certain number of hours, and the y value represents a certain number of pages read, you know? Does that make sense? And so one thing that I wrote but didn't like really highlight is that the y-intercept is 0b, and the x-intercept is a 0. So now I'm really emphasizing the 0, okay? So you'll see that right here, we don't have one. This is just a 0.4350. So this is one of those ones where we have the slope and then a point. Okay, so it would have been nice if we had the words there, but we don't have the words. So now we just got to sketch the graph. Which of the following could be a graph of the relationship? Well, he read the book cover to cover, so he started with no pages read. And then after 4 hours, he had read all the pages. So we want to see one that starts from 0, 0. And, oh, no, we don't want it to start from 0, 0 because we could talk about it like he had a certain number of pages to read, and then the slope is pages read. So our slope could be negative 55. So he has a book to start, and then he's reading it, and the amount of pages he has left to read is going down. I only say that because I don't see my 0, 0 graph. So it can't be A, because if we're starting here at a positive number, that would be pages to read, and then you got more pages to read as you read. That doesn't make sense. I think it's got to be C. It's got to be C because he has a certain number of pages to read here. Certain number of pages to read here. And then he's reading the pages. And then at 4 hours, he has read all the pages. So that's why I think it's C. And so I'm going to select it. Okay, we got it. All right, let's do one more of these because I think these are a little tricky. Do you think these are tricky? Okay. Oh, I see this. I have this thing stuck. It's stuck. You know what? I don't know. I'm going to press refresh and hope for the best. A lake near the Arctic Circle is covered by a 2-meter thick sheet of ice. When the spring arrives, the warm air gradually melts the ice, causing its thickness to decrease at a constant rate. After 3 weeks, the sheet of ice is only that many meters thick. So now I'm reading this here, and I'm noticing we have weeks and we have meters thick. right? So this looks like the 0.3, 1.25, and it is covered by a 2 meter thick sheet of ice during the cold winter months. That is the beginning of the ice melting, right? We're talking about melting ice. Well, during the winter, it's not melting, hopefully. And so we have 0, 2, and then you see after 3 weeks, it's down below 2, right? It's melting. So what is this? Do you know? It's the y-intercept. So the point and a y-intercept. All right. I think that I have done all I'm going to do with that one. Now it's your time to try it. But the cool thing is, all that work will pretty much get us the concept of the other assignments as well. All right, write this one down. Madhavi scoops a bowl full of cereal out of a container that has a mix of oat and wheat cereal pieces. She graphed the relationship between the possible masses of oat and wheat cereal in her bowl. What does the y-intercept? Well, we know that's the beginning, right? It's also, let's look at the labels on the axes. Anytime we have a graph, look at the labels. So the Y label is the oat cereal. All right. So the starting amount of oat cereal, or the amount of, here's another way to think of it. We know that the y-intercept is, well, it's like what, 0.28 or 29 or something like that. So it's like that, right? X represents wheat. So as if we had all oats, that is the amount, that's the mass of oats in the cereal. So let's see what we can find. The mass of the cereal, if it's all oats, there we go. Okay. Oh, what feature of the graph? So the rate of change. I don't even have to read that. The rate of change. Look at that. Okay. The slope in this. So you know what? Go for it. You can do this. Use those keywords. Oh, tables. Word problem tables. Isabella filled her pool with water at a constant rate. The table compares the remaining volume of water left to fill the pool in liters and the time since Isabella started filling the pool in minutes. Okay, so let's make sense of this problem. She's filling a pool and the remaining water to fill. So we see that's going down. What is the size of the pool? Well, the size of the pool, what part of the linear function would that be? Well, these numbers are stuff for, amount remaining to be filled. At 0 minutes, it all needs to be filled. So whatever we get for the y coordinate at 0 minutes is the y-intercept, and it's also the size of the pool. So let's just work backwards here. Okay, so we know we're going by twos. And so what is 112 minus 76? That'd be 6. Okay, so that's 36. So we are subtracting 36. That's subtracting 36 most likely, right? So in order to go backwards forward all the way to 0, that's like subtracting 36 twice. And what's 36 times 2? 72, right? So subtract 72. And so what is 148 minus 72? Or adding 72, right? Because we want to find how big that pool is. And so that would be 5 plus 7 is 12 to 220. Is that right? Let's find out. 220. I got it. All right. So that was, how did we do that? I identified that they're asking for the y-intercept because I made sense of what these variables represented in terms of the problem. And then I found the y-intercept. By working backwards, I know the y-intercept was an x is 0. You could do the same thing if you knew they wanted the x-intercept. And if they want the slope, just use the slope formula. And so those are the three things that you'll be asked to find. Same three things we'll be asked to find in this assignment, just instead of a table, we're starting with a graph. Wilbur landed his plane. The plane's elevation relative to the ground in meters as a function of time and seconds is graphed. Okay, so right away, I'm noticing my units are time in seconds. Well, that's the quantities are time and elevation, and the units are seconds and meters. How fast did the plane descend? How fast something happens is, what do you think? That's the slope, because that is a rate, right? How fast something happens is a rate. So we want to know the slope from the graph. So let's find some points on the graph that we can identify, and then we're gonna find the slope. So this one right here, that point is the y-intercept, and this is I think it's 8,500. Then what about the x-intercept? Or actually, even easier than that. It goes, well, now what is the interval here? 1, 2, 3, 4. So 400 divided by 4 is 100, right? So this is 100. And so it goes down by 500 and over 100 to get from here to here. For the interval on the y-axis is 500. This graph is going, it's like the slope in terms of the boxes is down 1 over 1. So then we just need to know what are the intervals. So the interval on the y-axis is 500. So we're going down 500. And the interval on the x-axis is 100. So we're going over 100. And then we can simplify. So cross out, -5 over 1, or just -5. So the slope is, descending at 5 meters per second. All right. Cruising along. And now, at long last, we've made it to the last one. Linear equations, word problems, graphs. Didn't I just do that? Okay, let's just make sure. Linear graphing, linear. Okay. How much slushy did? Okay, so we should do this one. This one is a little bit different here. Sean is drinking a slushy as fast as he can. Go, Sean. The amount of slushy left in the cup in milliliters as a function of time and seconds is graphed. How much slushy did Sean drink every 5 seconds? So, every 5 seconds. So let's talk about this. We know we want amount per 5 seconds, right? X liters. And the slope is the amount per 1 second. Slope. All right, so let's find the slope, and then we'll use a proportion to figure out the rest. That's what I'm gonna do. So I see for the slope, I see that we start at 0, 600. And then as I look, the next point is right there, and that is 25, 400. Okay, so I'll just set up a little slope formula to find the slope. 0 minus 25. And so we get 200 over negative 25, which is, it's like negative 50, right? So the slope is negative 50. I can just go ahead and erase that. Where is my eraser? I don't know where my eraser is. Negative 50. Negative 50 liters every 1 second. So now I'm going to set up my proportion. Negative 50 over 1 is equal to x over 5. Okay, so this is the question. This is the slope I found, and I can set them equal. So 50 times 5 is 250, negative 250. All right, so negative 250. Maybe I made it harder than it needed to be. I don't know. Let's see if how much slushy did he drink every 5 seconds? Maybe I did it wrong. Okay, so let me just pause the video really quick and figure out the mistake that I made before I come back here. This is not good. Mr. Field did some wrong arithmetic, but I didn't press check. I figured it out. You probably already know that when we divide, so I did that work and I got that, and that's going to be -8, not -5 or whatever I said it was. So the slope is -8 milliliters per second. And then so in 5, so per 1 second. So in 5 seconds, we could just, we can set up the proportion, but we just multiply. So -8 times 5 is -40. Hopefully that's down there. -40, 40. Look at that. All right. See, I messed up just in my division, but thankfully it's multiple choice and I didn't see the answer and I got to go back and figure it out. Thank you, Khan Academy. That was good. Gave me an opportunity to keep persevering, and I hope you get the same opportunity and that you post in the organizer. Bye.